Hello and welcome back, and in this video we'll take a look at some of the algorithms and we'll try to calculate the execution time using this empirical relation. Without further ado, let's get started. First we'll start with the sequential algorithm. These algorithms are probably the simplest to interpret and to calculate the execution time. Let's get started. So this is a simple example, program to print the text hello world, and it's a sequential. The reason is that first we will include the standard input output header file, and we have a main function, and from this point onwards the execution starts, and then we have the parenthesis. Within that we have the main code, which is to print the text hello world. We use a function called printf, and this program is written in C, and these are some of the important elements to be considered, and we have incorporated all the things that are required to print the text hello world, and we got the output as hello world as well, right? So this is a sequential. The code executes in a sequential manner. Let's take a look at the execution time of this algorithm. I'll just taking this code snippet, and I've just cropped it here, and we have this from our empirical relation. Remember, A stands for assignment operation, and B stands for comparison, C stands for increment, and D stands for print or the display. And we try to see map these operations in the code, and we don't have any assignment operations here, and also the comparison and increment operations are not there, so hence the occurrences of these are 0. But we do have a print or display option, which means like print function is print or display operations, and hence we have got one element of that particular nature, like printf. So I've just got to accept from this code printf, which corresponds to the print or the display, so which is just one occurrence, right? So we'll apply these things in the empirical relation. So it's a 0 times A plus 0 times B plus 0 times C and 1 times D. So in the end we only got 1 into D, and we can ignore the constant term D, and that will leave us with 1 unit. So this is just a constant unit, and from this we can see that we probably have only one operation in this, and that algorithm and this particular algorithm takes just one constant unit time. So the execution time of this particular program or the algorithm is just like 1 unit, right? So let's take a look at the other example, when which we'll have the scope for assignment and other related operations in a sequential algorithm. So this is another sequential algorithm. This is the program to add the given two numbers, right? So the program is fairly the same. In this case, we declare the int main, because the return function is an integer, whereas this is the return is a character, but we have given a void main, so which means that we don't have to explicitly mention the return function to exit the program. So hence it's a simple code, but in the next program it is returning an integer value. So we have got int main function, and then you can see the program executes from this line onwards, and you can see it executes in a sequential manner, like 3, 4, 5 and so on, right? And then we have declared the variables A, B and C, and A, B and C being an integer variable, so we declared that. And we have initialized the data or the value A equals to 2 and B equals to 3, and A and B here represents the initialized variables, whereas D here is uninitialized variables. And in the next line we have a formula kind of thing, or the assignment, which is C equals to A plus B, which means that C takes a value of A and B. So we have got two operands, A and B, and the operation is an addition, so C performs addition of A and B, and that gets print in this function printf. The value of C is equals to %D. %D talks about the integer value, the return of this particular C variable, which is an integer. So we have got %C comma %D comma C, and we have the semicolon to execute this, and then this program gets terminated here. And the return, you can see the output, you can see the value of C equals to 5, so just 2 plus 3 is 5, and this is fairly the sequential program. And let's take a look at the code snippet of this, and we compare that with the standard table which we have prepared using the empirical relation. And you can see assignment, comparison, increment and display, A, B, C, D. And we have got 3 assignment operations here, like A equals to 2, b equals to 3, and c equals to a plus b is also an assignment operation, hence we have got 3. But do not confuse this a and this, since I've used the same notation, but you can even give x, y, and z. So you can print a z here or something like that. So this a, b, c, d represents the notational thing for the operations, like assignment operation, comparison operation is b, and increment is c, and print or display is d, right? Something like that. So which means the occurrences is thing. Remember in the empirical relation formula, we talked about sum of all assignment operations. So which means that since we have got 3 assignment operations, the occurrences are generally added, like 1, 2, and 3. So hence we have got this 3. We don't have any comparison operations in this case, and increment operations is also not there, but we do have a print or display options, which is printf function, and that occurs only once. So a total of 3 and 1. So 3 times a plus 0 times b plus 0 times c plus 1 times d, that will add us to 3a plus 1d. And you can probably ignore the constants a and d, so that will be like 3 plus 1 is equals to 4 constant unit, right? So the execution time of the algorithm is 4 units, because 3 assignments and 1 display. So the time, if you perform this in the computer, and you can even find the actual execution time in millisecond or even microsecond, depending upon your processor, right? So that is actually 4 times the processor capacity, and I mean the time in which it's calculated, right? So it's 4 units stands for like 4 operations gets performed, and then it's just an unit, and you can even convert this into seconds depending upon your processor speed, and that gets calculated. But this is the guideline. It takes 4 units of time, right? So in the next video, we'll take a look at the iteration algorithms or iterative algorithm, in which we have got some scope for the comparison and increment operations. I hope you really enjoyed this video. Have a great day. Bye-bye.